Hi, welcome to In and Around Computer. In this video, we are going to see what is segmentation in the operating system. The last video we have seen what is meant by paging and various techniques of paging, which is a memory management technique in OS. And now we are going to see what is segmentation. This is another way of dividing the addressable memory, and it's also another scheme of memory management where a process is divided into segments. Like paging, this segmentation divides or segments the memory, but there is a difference that the paging divides the memory into a fixed size, and on the other hand this segmentation divides the memory into variable segments, and these are then loaded into the logical memory space. That we can see in this video how this segmentation divides the memory into variable segments rather than dividing the memory into fixed size like that method of paging divides. A program is basically a collection of segments, we can say, and such a segment is a logical unit. That is, this segmentation divides the memory into segments in the user's view, we can say. Since a program has a main program, procedure, function, method, object, local variables and global variables, symbol, table, common block, stack and arrays. So this segmentation divides the memory into segments according to the things in the program. So it divides the memory in the user's view. So unlike the method of paging that that will not divide the memory in the user's view, it will simply divide into fixed segments. But this segmentation divides the memory in the user's view. And now we can move the types of segmentation. Then we can see how the segmentation is done. There are two types of segmentation: virtual memory segmentation. That is, with this type of segmentation, each process is segmented into n divisions, and the most important thing is that they are not segmented all at once. And this simple segmentation, each process is segmented into n divisions, and they are all together segmented at once exactly, but at the runtime, and can be non-contiguous. That is, that may be scattered in the memory. So these are the two types of segmentation. And now why this paging came, that is, the issues with paging mechanism gave rise to this segmentation. And using paging, the same function is divided into many pages. That is, resulting pages might or might not be put in the memory simultaneously. So if for a function to run, everything must be put in the memory simultaneously, but using paging, some pages, that is, since the same function is divided into many pages, some functions may or may not be put in the memory, which obstructs the execution. So for the process to run, the CPU must load the many pages to provide all the required code for processing. So thus segmentation, that is, which is the code division into modules, was created so that similar code might be merged into one block. So that will be one segment, so it will be easy to load for processing. So instead of loading multiple pages of the same function, while that is using paging. Hope you'd be understanding why this segmentation came into existence. So Now we can move to the basic method of segmentation. That is a computer segment system that is using segmentation as a logical address space that can be viewed as multiple segments. And the size of the segment is of the variable that may grow or shrink. Each segment has a name and length. For simplified implementation, the segments are numbered. So, thus referred to as segment number rather than the segment name. Thus, the logical address consists of two tuples, that is segment number and the offset, where the segment number that is used to represent the number of bits that are required to present the segment, and the offset segment offset is used to represent the number of bits that are required to represent the size of the segment. So this is about the basic implementation of this segmentation. Now we can move to the segmentation architecture, that is what are present in this segmentation. That is segment table, which has all the information about the segments. That is, generally there is no simple relationship between the logical addresses and the physical addresses in the scheme. The mapping of this two-dimensional logical addresses into one-dimensional physical address is done using the segment table. That is, this segmentation involves a logical address that is which is two-dimensional, that is it has two tuples that we already said. So this is done using the segment table, and this is segment table is stored as a separate segment in the main memory. And the table that stores the base address of the segment table is commonly referred to as the segment table base register. So these are the things that are present in segmentation. Now we can see what are all the entries that are present in the segment table. That is segment base address, that is and a segment limit, segment table base register, and this segment table length register. So for implementing this segmentation, the segment table will have these four things to find the particular segment in the memory. And now we can see what is a segmentation hardware. That is this logical address generated by the CPU will have two parts. That is how this segmentation is done. Now we can see that is segment number that is used as an index to the segment table. Offset, that is it must lie in between 0 and the segment limit. And in this case, if the offset exceeds the segment limit, then trap is generated. If and correct offset plus segment base is equal to the address in the physical memory. So like that, this physical address is mapped to the logical addresses, thereby indicating the segment in the memory. So this is what done in the segmentation. Subscribe to my channel if you feel content.